Good morning, Doc Melo. Good morning, everyone. My name is Alan Ragingan, and I will be discuss today the chapter 5, the IT infrastructure and emerging technologies. Under of this is the contemporary hardware and software platform trends and the management issues. Contemporary hardware platform trends. The exploding power of computer hardware and networking technology has dramatically changed how businesses organize their computing power, putting more on this power on networks and mobile handheld devices. We look at the 8 hardware trends: the mobile digital platform, consumerization of IT, grid computing, virtualization, cloud computing, green computing, and the high performance power saving processors and autonomic computing. In the next slide, we will discuss the mobile digital platform. Mobile digital computing platform have emerged as an alternative to PCs and larger computers. Smartphones such as the iPhone, Androids, and the Blackberries smartphone have taken on many functions of PCs, including transmission of data, surfing the web, transmitting email and instant messages, displaying digital content, and exchanging data with internal corporate systems. The netbooks includes small lightweight netbooks optimized for wireless communication and internet access. Tablets, computers such as the iPad, and digital e-book readers such as Amazon Kindle with web access capabilities. And the other one is the wearable devices such as the smartwatches and the smart glasses. Smartphones and the tablet computers are becoming an important means of accessing the internet. These devices are increasingly used for business computing as well as for consumer application. The consumerization of IT and the BYOD. First is the consumerization of IT. It, it includes not only mobile personal devices but only business uses of software services such as Google and Yahoo Search, Gmail, Google Apps, Dropbox, and even Facebook and the Twitter that originated in the consumer marketplace as well. This is the new information technology emerges in consumer market first and spread to the business organization or the forces businesses and IT departments to rethink how IT equipment and services are acquired and managed. The other hand, the BYOD or bring your own devices is allowing employee to use personal mobile devices in a workplace. The third contemporary hardware platform is the grid computing. Grid computing involves connecting geographically remote computers into a single network to create a virtual supercomputer by combining the computational power of all the computers on the grid. The business case for using a grid computing involves cost saving, speed of computation, and agility. The fourth one of a contemporary hardware platform is the virtualization. Virtualization is the process of presenting a set of computing resources, such as computing power or data storage, so that they can all be accessed in ways that are not restricted by physical configuration or geographic location. Allow single physical resources to act as multiple resources. For example, is run multiple instances of operating system, or the reduces hardware and power expenditures, facilitates hardware and centralization. For example of this is a server of mainframe can be configured to run many instances of an operating system so that it acts like many different machines. Virtualization also enables multiple physical resources such as the storage devices or the servers to appear as a single logical resource, as would be the case with storage area networks of grid computing. Virtualization makes it possible for a company to handle its computer processing and storage using computer resources housed in remote locations. The cloud, the cloud computing is a model of computing in which computer processing, storage, software, and other services are provided as a pool of virtualized resources over a network, primarily the internet. These clouds of computing resources can be accessed on an as-needed basis from any connected devices and location. The cloud computing consists of three different types of services. These are the infrastructure as a service or IaaS. Cloud infrastructure as a service is a customer use processing, storage, networking, and other computing resources from cloud services providers to run their information systems. For example, Amazon uses the spare capacity of its IT infrastructure to provide a broadly based cloud environment selling IT infrastructure services. The second one is the platform as a service. These are the customers use infrastructure and programming tools supported by the cloud service provider to develop their own application. For example, IBM offers a smart business application development and test service for software development and testing on the IBM clouds. And the last one is the software as a service or the cloud software as a service. These are the customers use software hosted by the vendor on the vendor's cloud's infrastructure and delivered over a network. Leading examples are the Google Apps, which provides common business applications online, and Salesforce.com, which also leases customer relationships management and related software services over the internet. Both charges users an annual subscription fee, although Google Apps also have a pared-down free version. Users access this application from a web browser, and the data and software are maintained on the provider's remote servers. And the cloud can be public or private, and it allows the companies to minimize IT investment and the uh, some has drawbacks or disadvantage of the concerns of the security and reliability. And the last one, hybrid cloud computing uh, model, where they use their own infrastructure for their most essential core activities and adopt public cloud computing for less critical system or for additional processing capacity during peak business period. Cloud computing will gradually shift from having a fixed infrastructure capacity towards a more flexible infrastructure, some of it's owned by the firm, and some of it rented from giant computer centers owned by the computer hardware vendors. In this figure, it illustrates the cloud computing and the different types of services. In cloud computing, hardware and software capabilities are a pool of virtualized resources provided over a network, often the internet. Businesses and employees have access to application and IT infrastructure anywhere at any time and on any device. By curbing hardware proliferation and power consumption, virtualization has become one of the principal technologies for promoting the green computing as the six contemporary hardware platform trends. Green computing or green IT refers to practices and technologies for designing, manufacturing, using and disposing of computers, servers, and associated devices such as monitors, printers, storage devices, and networking and communication system to minimize the impact on the environment. Reducing the power consumption has been a very high green priority. The information technology is responsible for 2% of total U.S. power demand, and it is believed to contribute about 2% of the world greenhouse gases. Cutting power consumption in data centers has become both a serious business and environmental challenge. Another way to reduce a high requirement and a hardware sprawl is to use more efficient and power-saving processor. Contemporary microprocessor now features multiple processor cores which perform the reading and execution of computer in instruction on a single chip. The seventh contemporary hardware platform is the high performance and power saving processors. A multi-core processor is an integrated circuit to which two or more processor cores have been attached for enhanced performance, reduced power consumption, and more efficient simultaneously processing of multiple tasks. This technology enables two or more processing engines which with reduced power requirements and heat dissipation to perform tasks faster than a resource-hungry chip with a single processing core. Today, you will find PCs with a dual core, quad core, 6 core, and the 8 core processors. The power or highly power efficient microprocessor is a cheap manufacturers, or example of this is the Intel or the AMD have developed microprocessors that minimize power consumption, which is essential for prolonging battery life in a small mobile digital devices. With large systems encompassing many thousands of network devices, computer systems have become so complex today that some experts believe they may not be manageable in the future. One approach to this problem is autonomic computing. Autonomic computing is an industry-wide effort to develop systems that can be configured themselves, optimize and tune themselves, heal themselves when broken, and protect themselves from outside intruders and self-destruction. So, we are done with the contemporary hardware platform trends. In the next slide, we will tackle the contemporary software platform trends. So we are now in the contemporary software platform trends. There are four major themes in contemporary software platform evolutions. First is the Linux and the open source software. Second is the Java or the Java, HTML, and the HTML5. Third is the web services and service-oriented architecture. And the last is the software outsourcing and cloud services. The next slide we will discuss the uh, Linux and open source software. Perhaps the most well-known open source software is Linux, an operating system related to Unix. Linux was created by the Finnish programmer Linus Torvalds and first posted on the internet in August 1991. Linux applications are embedded in cell phones, smartphones, netbooks, and consumer electronics. Linux is available in free version downloadable from the internet or in low-cost commercial version that include tools and support from vendors such as Red Hat. The open source software is a software produced by a community of several 100,000 programmers around the world. According to the leading open source professional association, opensource.org, Open source software is free and can be modified by users. Work derived from the original code must also be free, and the software can be redistributed by the users without additional licensing. Example is for example is the Apache Web Server and the Mozilla Firefox browser and the Open Office. The software for the web. Java is an operating system independent, processor independent, object-oriented programming language that has become the leading interactive environment for the web. Java was created by James Gosling and the Green team of Sun Microsystems in 1992. In November 13, 2006, Sun released much of the Java as open source software under the terms of the General Public License, completing the process on May 8, 2007. The HTML or the Hypertext Markup language is a page description language for specifying how text, graphics, videos, and sounds are placed on the web page and for creating dynamic links to other web pages and objects. Using these links, a user need only point at a highlighted keyword or graphic, click on it, and immediately be transported to another document. The latest evolution of HTML is called HTML5. Solves this problem by making it possible to embed images, audio, video, and other elements directly into a document without processor-intensive and add-ons. HTML5 will also make it easier for web pages to function across different display devices, including mobile devices as well as desktop, and it will support the storage of data offline for applications that runs over the web. The third contemporary software platform is the web services and the service-oriented architecture. Web services refers to a set of loosely coupled software components that exchange information with each other using universal web communication standard and languages. They can exchange information between two different systems regardless of the operating systems or programming languages on which the systems are based. They can be used to build open standard web-based application linking systems of two different organizations, and they can be also used to create applications that links disparate system within a single company. The foundation technology for web services is the XML or the extensible markup language. This language was developed in 1996 by the World Wide Web Consortium, W3C, the international body that oversees the development of the web, as more powerful and flexible markup language that hypertext markup language or the HTML for web pages. By tagging the selected elements of the content of the documents for their meaning, extensible markup language or the XML makes it possible for computers to manipulate and interpret their data automatically and perform operations on the data without human interventions. The collection of web services that are used to build a firm software system constitute that is known as a service-oriented architecture or the SOA. A service-oriented architecture is a set of self-contained services that communicate with each other to create a working software application. Business tasks are accomplished by executing a series of these services. Software developed reuse these services in other combination to assemble other application as needed. For example of this is an invoice service to serve whole firm for calculating and sending printed invoices. This is the last contemporary software platform, the software outsourcing and cloud services. Today, many businesses or business firms continue to operate legacy systems that continue to meet business need and that will be extremely costly to replace. But they will purchase or rent most of their new software application from external sources. These are the three external sources for software. The software packages from a commercial software vendor or the outsourcing customs application development to an external and the cloud-based software services and tools. First is the software package. It is a pre-written commercially available set of software programs that eliminates the needs of a firm to write its own software program for certain function, such as payroll processing or the other handling enterprise application. Software vendor such as SAP or the Oracle PeopleSoft have developed power software packages that can support the primary business processes of a firm worldwide, from warehousing, customer relationship management, and supply chain management to finance and human resources. This large-scale enterprise software system provides a single, integrated worldwide software system for firms at a cost much less than they would pay if they develop it themselves. Second one is the software outsourcing that enables a firm to contract customs software development or maintenance of existing legacy programs to outside firms, which often operates offshore in a low-wage area of the world. For the third one is the cloud-based software, and the data it uses are hosted on a powerful servers in a massive data centers. It can be accessed with an internet connection and a standard web browser. In addition to free or low-cost tools for individuals and small businesses provided by Google or Yahoo, enterprise software and other complex business functions are available as service from the major commercial software vendors. Instead of buying and installing software programs, subscribing companies rent the same functions from their services, with the users paying either on a subscription or per transaction basis. Services for delivering and providing access to software remotely as a web-based services are now referred to as a software as a service. A leading example is Salesforce.com, which provide an on-demand software services for customer relationship management. To manage their relationship with an outsourcer or the technology service provider, firms need a contract that includes a service level of agreement or SLA. The SLA is a formal contract between customer and their service provider that defines the specific responsibilities of the service provider and the level of service expected by the customer. This SLA typically specify the nature and the level of service provided, criteria for performance measurement, support options, provision for security and disaster recovery, hardware and software ownership and upgrades, customer support, billing, and condition for the terminating the agreement. And that is the contemporary software platform. Creating and managing a coherent IT infrastructure raises multiple challenges. Below are the management issues. First is the dealing with platform and technology change, including cloud and mobile computing. Management and governance. And the last is the making wise infrastructure investment. Dealing with platform and infrastructure change. As the firms shrink or grow, IT needs to be flexible and scalable. As firms grow, they often quickly outgrow their infrastructure. As firms shrink, they can get stuck with excessive infrastructure purchase in a better times. How can a firm remain flexible when most of the investment in IT infrastructure are fixed costs, purchases, and licenses? So how will does the infrastructure scale? IT infrastructure scaling is when the size and the power of an IT system are scaled to accommodate changes in storage and workflow demands. Scalability refers to the ability of a computer products or system to expand to serve many users without breaking down. New applications, mergers and acquisitions, and changes in business volume or and impact computers workload and must be considered when planning hardware capacity. Firms using mobile computing and cloud computing will require new policies and procedures for managing these platforms. They will need to inventory all their mobile devices in business use and develop policies and tools for tracking, updating, and securing them for controlling the data and application that run on them. Using cloud computing and software as a service will need to fashion new contractual agreement with remote vendors to make sure that the hardware and the software for critical applications are always available when needed and that they meet corporate standards for information security. It is up to business management to determine acceptable level of computer response time and ability for the firm's mission-critical systems to maintain the level of business performance they expect. Uh, Management and governance. So, who controls IT infrastructure? Uh, Whoever controls the infrastructure controls the business. So, the ability to identify where a given application resides, where a compromised computer is connected into the network, where packet loss is occurring, or identifying the origin of the failure has become increasingly important. Controlling the infrastructure either helps or hinders the smooth operation of the business. If the infrastructure isn't working properly, the applications upon which the business depends will not work. Therefore, the business stops. So, whoever controls the infrastructure controls the business. And how should IT department be organized? If it's centralized, the central IT department should makes decision. If it's decentralized, the business unit IT departments make their own decision. And how are costs allocated between divisions and departments? Cost allocations benefits businesses by managing the cost and avoiding unnecessary or unwarranted spend associated with IT and telecoms assets and services. It provides transparency of usage and clarity into cost and potential savings through identifying zero usage and discrepancies on the continual basis. For the making wise infrastructures investment. So a related question is whether a firm should purchase and maintain its own IT infrastructure components or rent them from external suppliers, including those offering cloud services. The decision either to purchase your own IT assets or rent them for external providers is typically called the rent versus buy decision. In cloud computing, may be a low-cost way to increase scalability and flexibility, but firms should evaluate this option carefully, considering security requirements and impact on business processes and workflow. In some instances, the cost of renting of software adds up to more than purchasing and maintaining an application in-house. Yet, there may be benefits to using cloud services if this allows the company to focus on core business issues instead of technology challenges. The total cost ownership, or the TCO model, the actual cost of owning technology resources includes the original cost of acquiring and installing hardware and software, as well as ongoing administration costs for hardware and software upgrades, maintenance, technical support, training, even utility and real estate costs of for running and housing the technology. The total cost of ownership, or the TCO model, can be used to analyze these direct and indirect costs to help firms determine the actual cost of specific technology implementation. For the hardware software account for only about 20% of total cost ownership, hardware and software acquisition cost accounts for only 20%, so managers must pay close attention to the administration costs to understand the full cost of the firm's hardware and software. It is possible to reduce some of these administration costs through better management. Many large firms are saddled with redundant, incompatible hardware and software because their department and divisions have been allowed to make their own technology purchases. TCO, or the total cost ownership, can be reduced. These firms called reduce their TCO through greater centralization and standardization of their hardware and software resources. Companies could reduce the size of the information system staff required to support their infrastructure if the firm minimizes the number of different computers or models and pieces of software that employees are allowed to use. In centralized infrastructure, system can be administered by a central location, and troubleshooting can be performed from that location. Uh, and that's the end of my report for the chapter 5 in the IT infrastructure and emerging technologies. Thank you for listening. Uh, thank you po